Welcome to our C# Programming for Beginners course. Whether you're completely new to programming or looking to expand your skills, this course is designed to guide you through the fundamentals and beyond. The course is structured into several modules, each focusing on key aspects of C# programming. Module 1, set up your environment and get familiar with Visual Studio. Module 2, start programming with basic syntax and structure. Module 3, explore data types and variables. Module 4, working with strings and more. Module 5, use flow controls with if statements, loops, and other control structures. Module 6, using functions and methods to write reusable code. Module 7, learn object-oriented programming with classes, objects, and more. Module 8, handling and debugging errors. Module 9, File I/O. Along the way, you will also learn some finer tricks of the trade to make writing C# code easier. Make sure to code along with the tutorials. Practice is key. Try out different things and experiment with the code. It's a great way to learn. Regular practice will help reinforce what you learn. Let's get started and happy learning. In this module, we'll take a look at reading and writing files. First, we'll discuss how to add content files to your project, such as text files, etc. Then we demonstrate how to read lines of text from a text file, and in the case of a character-separated value file, how to convert the CSV content to objects. Then, how to write these objects back to a text file. We'll discuss how to access the file system through the directory and path objects. And finally, how to manipulate the files using the file object. We'll create a new project in our solution and set it as the startup project. If you prefer, you can continue on an existing project or create a new solution. Please refer back to Module 1 for the detailed steps on how to create a project. Let's add a text file to our project to work with. Right-click the project name and select Add New Item. In the list of available components, scroll to find and select the text file type. We'll name it sample.txt, then click the Add button. Once added, the text file will open in the editor. We'll add 2 lines of some text data. You can click the Save button on the top toolbar to save the changes. We also need to tell the IDE that we want this text file to be part of the output when we build our project. Right-click the text file and select Properties. Then, set the build action to Content and select Copy if newer. To see how this works, we'll build our project. After the build completes, we can go to our file system, to the output directory of our project. Here we can see the sample text file was added to the output directory where our executable was generated. It's important to note that if we didn't set this file as a content file, the compiler wouldn't know to add it to the final output when the project is built. Content files are typically files like these that are not part of the executable code, but are still needed by the app to function correctly. These could be text files, images, data files, configuration files, etc. We also set the file's copy instruction to copy if newer. So if we made changes to this file in the editor, the new changes will be copied to the output directory when the project is built. Let's write some code to read the new sample text file line by line. In the program.csfiles main method, we start by specifying the path to the file we want to read. In line 7, we first get the base directory of the application. This is the directory from where the app is executed. In line 8, we use the pathObjectsCombine method to add the file name to the base directory's path. Then, we simply display the full file path to the console. When we read from text files like these, we need a stream reader object. A stream reader will open the file and read its contents as a stream of characters. But we must also be sure to close the file and dispose of the stream reader when we're done. To ensure this, we use the using statement in line 12. This says, create for me a stream reader object using the given file, then do whatever you want to with the stream reader in the block that follows, and the using statement will make sure the file is closed and the stream reader is disposed of. Inside the using block, line 14 uses the stream reader's readLine method to read the next available line in the text file and stores it in a string variable. Then it uses a while loop, first checking that the last line we read actually contains something. In other words, it's not nothing or null. If the line variable does contain something, display it. Then, read the next line and continue looping, displaying and reading lines until there's no more lines in the file. After that, the using block ends and it neatly closes and disposes any open resources. When we run this app, the first line displays the full file path, then displays each line of text it read from the file. As a demonstration, let's see how we can pull the data we read from the text file into an object. Looking at the sample text file again, we can see each line has values separated by a comma. This is a typical character-separated value file, or CSV file. There's an ID field, first name and last name, an email field, and a phone number field. We'll add an object class to our project to hold the 5 fields. Right-click the project name and select Add Class. We'll give it the name person and click the Add button. In the class definition, we'll add 5 string properties to represent the fields from the text file. As is good programming practice, we'll set the default values of each property. In this case, we can just set them as empty strings. Next, we create a constructor that accepts a string. We will pass the line of text we read from the text file into this constructor when we instantiate a person object. The constructor calls a private parseFields method in the class to convert the string into the respective property values of the object. In the parseFields method, we create an array of strings to hold each field in the line of text, then use the split method to split the line of text whenever it encounters the comma character. After the split, we check that there are actually 5 fields in the array of strings. Otherwise, it will just return with the default empty values of the properties. If there are 5 strings in the array, We assign each one to the respective property. As a bonus, we add a public method to display the values of the properties. Back in the main method, where we simply displayed the line of text to the console, we now instantiate a person object using the person class's constructor and pass the line of text to it. Then we call the person object's showPerson method to display the person's details. When we run this app, instead of just showing a line of raw data, it now neatly displays a person's details. The next obvious step is to be able to write to the text file. First, in the person object, we add another public method to turn our person object into a line of text to write to the file. The serializePerson method simply uses the properties of the person object and returns them in a comma-separated string. Back in our program CS File, we add a createSampleFile method. This will accept the file path where it must write the people data. In the first section of the method, we create an array of person objects using the person object's constructor method to add persons into the array. In the second part of the method, we make use of the using statement again, but this time we use the streamWriter instead of the streamReader. Then, we loop through each person object in the people array, call the person object's serializePerson method to turn it into a string, and write that line to the file using the streamWriter's WriteLine method. On top, in the main method, we call the createSampleFile method with the file path. Then just after that, it will read the file again and display its contents. When we run the app, it creates the file, then reads the file and displays the result. There's something to be aware of when creating a streamWriter, like we do here in line 36. In this format, the streamWriter will either create the file if it doesn't exist or overwrite whatever is inside the file. If you want to append to an existing file, then you need to add a true argument in the new streamWriter statement. This tells streamWriter to append instead of overwriting a file. Let's run the app again. Now we can see an additional 4 records were appended to the text file. C# contains several readers and writers. The streamReader and streamWriter is by far the most common for working with text files, while others like the binary reader and writer can work with binary data, for example, writing variables of different data types to a file. Along with these readers and writers are serialization and binary formatting tools. For now, simply be aware there are different ways to read and write files. C# provides objects like path, directory, and file to access and manipulate your file system. In this example, we'll demonstrate how to read the folder and file names from a given path. In line 9, we defined a string variable called examplePath to hold the value of the path we're going to work with. But notice we had to use double backslash characters because C# treats the backslash as an escape character. We fix this in line 12 by adding an @ character in front of the string of text. This tells C# to treat the backslash character as a literal backslash and not an escape character. Now we can define our path without double backslashes. In this example, we created 3 methods. The showFolders method displays the name of the folders in the current path. The showAllFolders will display the full path name of all the folders and subfolders in the current path. And finally, the showFiles method will display the names of all the files in the current path. When we run the application, we see the following result. At the top, we simply displayed the current path. As you may have noticed, this is the path to my Module 9 projects folder. It then displays the names of the folders in that path. Then, the full path names of all the folders and subfolders, and a list of the files in my Module 9. Let's look at how we accomplish this. In the showFolders method, on line 26, we use the directory object's getDirectories method to retrieve an array of the folder names from the given path. Then we loop through the string array and display each folder name. But these folder names contain the full path of each folder, so we use the path object's getFileName method to return only the last part of the path, which is the folder's name. In the showAllFolders method, we use the directory object's getDirectories method again, but But this time, we also give it a search pattern of an asterisk, meaning all directories, and a search options value of all directories. This means it will search down into the folder structure to retrieve the subfolder names. Then, we loop through the array and display the full path names of each folder. Our final method, the showFiles method, uses the directory object's getFiles method to retrieve the names. Again, the full path of each file will be retrieved. So when we loop through the array, we use the path object's getFileName method to get only the actual file name part from the path and display that. The last thing we're going to show in this module is C#'s file object. This is a pretty powerful object. It can create or overwrite files, delete, copy, and move files, check if a file exists, and also read and write all text to and from a file. To demonstrate some of the file object's methods, we first create another content text file in our project called stuff.txt and add some arbitrary text into it. In our program .cs file, we start by setting up the path to the stuff.txt file. In lines 12 and 13, we use the file object's exists method to check if the file exists. Then we're going to copy the stuff.txt file to another file called stuffcopy.txt. So first we set up a path to the destination file and check if it already exists. If the file already exists, use the file object's delete method to delete the destination file. The last section copies the stuff.txt file to the destination stuffcopy.txt file. Again, it checks if the destination file exists to confirm the copy was successful. There's an additional parameter in the file's copy method. By adding a true or false, we can tell the copy method if it should overwrite the destination file if it already exists. We can go to our file system to visually confirm that the new file copy exists. Congratulations on completing the C# beginner course. We hope you enjoyed this course and encourage you to continue on your exciting journey in C# programming. You can review any of the modules by following the links in the description below. Remember to subscribe to our channel to keep up to date with the latest new courses at Learn with James.